Hello and welcome. My name is Gaurav and today we'll get to know about a very important concept of climatology, that is the Coriolis force. Now this force is very important because it plays an important role in deciding the wind pattern in the atmosphere, and also it plays an important role in the genesis of the cyclonic condition. Okay, so we'll discuss both of them, but before that, first of all we need to know what actually is a Coriolis force. So if we go with the basic definition of this term, we can say that Coriolis force is a deflective force which is generated due to the rotation of a Earth. Okay. Now to make it more clear, suppose that you are taking your flight from New Delhi and your destination is Bangalore. So now why I had chosen these two cities? Because both of these cities are situated almost at the same longitude. Okay. So if your pilot is not aware with the Coriolis force, he is expected to land in Bangalore, but because of the Coriolis force or because of the deflection in a wind, he will land to the somewhere around to the west of Bangalore. Okay. So now that is why all the pilots has to do some corrections every mile so as to stay on a course. Okay, so this is all about this is an example of Coriolis force. Now one more thing again I wanted to focus on, that why is there a deflection in a wind? So it is only because of a rotation of a Earth. Okay, now if we'll see the magnitude of the Coriolis force, one formula has been derived for this. That is 2v sine theta. Okay, where v is the velocity of wind and theta is the latitude. Okay, so as you can see from here, that Coriolis force is directly proportional to the velocity and also it is directly proportional to the latitudes. Okay, now if the velocity of wind increases, it means Coriolis force also increases and there is a more deflection in a wind, you can see. Now in the second quantity, suppose that this is the Earth and this is the 0 degree latitude and we call it equator, and this is the 90 degree latitude and this is the pole. Now if the value of theta is 0, if I will put here, then sine 0 is 0. It means what? Coriolis force also becomes 0. So we can say that at equator there is no Coriolis force at all. Similarly, if the value of theta is 90 degree and if I will put it here, then sine 90 is 1, and from here you will see that Coriolis force is maximum. So from this formula we can say that Coriolis force at pole is maximum and it is 0 at equator. In other words, we can say that the Coriolis force is increasing while we are going from equator to the poles. Okay, so this is all about the magnitude of the Coriolis force. Now if we'll see the impact of Coriolis force on a wind, it has been observed that the wind is deflected to the rightward side in the northern hemisphere, while in the southern hemisphere there is a leftward deflection in a wind just because of the Coriolis force. Now if we'll see the whole pattern in the pressure belt of Earth, so see, this is the pressure belt of Earth, where this is the equatorial low pressure belt, this is the subtropical high pressure belt, this is the subpolar low pressure belt and this is the polar high pressure belt. Now we know that wind is blowing from the high pressure to the low pressure. So if we'll consider these two belts, so the direction of wind is like this, but because of the Coriolis force in the northern hemisphere, you will see there is a deflection in a wind in the rightward side. Okay, so this is the direction of a wind in the northern hemisphere between these two pressure belts. Similarly, in the southern hemisphere, you will see that if this is the direction or this is the standard direction of a wind, there is a leftward deflection. Okay, and we are calling it trade winds. Okay, now between these two belts, you know that this is the subtropical high pressure and this is the low pressure belt. So the wind, that the direction of a wind is to the south to the north. Okay, and this is the standard direction, but because of the Coriolis force, it will bend to the right side. Okay, so this is the direction and we are calling it westerlies because they are originated from the western side. In the southern hemisphere, this is the standard direction and it will shift it to the leftward side. Okay, so this is the we also call it westerlies because they are originated from the western side. Okay, now at last, the wind which is coming from the high pressure polar region, if this is the standard direction, it will bend to the right side and we call it polar easterlies. Okay, similarly here, if this is the standard direction and they bend to the leftward side, so this is the direction you will see in the southern hemisphere and they are also called as polar easterlies. Okay, now all of these winds are the permanent winds we'll see throughout a year. Okay, so this is all about the pressure belt and the wind patterns. Okay, now if we'll see the impact of Coriolis force in cyclone, see the foremost requirement for the cyclonic condition is the low pressure zone at the center, and this low pressure zone is attracted by a wind which is coming comparatively from a high pressure area. Okay, so if this is the standard direction, but because of the Coriolis force in the northern hemisphere, this wind will deflect to the rightward side. Okay, and because of this, low pressure is intensified at the center and ultimately it led to a cyclonic condition in the tropical region. Okay, basically I am talking about the tropical cyclone here. Okay, now this is all about the Coriolis force and its impact. Okay, we'll discuss about the tropical cyclone in our next session and I hope you like my session. Thank you very much.